Hello, and welcome to the Computational Thinking course. My name is Rido Irwansyah from the Faculty of Engineering at Universitas Indonesia. In this video, we will explore the four pillars of computational thinking: decomposition, pattern recognition, data representation and abstraction, and algorithms. These pillars are the foundation of how we use computational thinking to solve problems. Even though the term comes from computer science, these skills are useful in any field: engineering, architecture, business, design, and also in everyday problem solving. Here is the outline for this short session. First, I will briefly revisit what we mean by computational thinking and why it is useful beyond computer science or programming. After that, we will look at each of the four pillars: decomposition, how we break a big problem into smaller parts; pattern recognition, how we notice similarities and trends; data representation and abstraction, how we decide what information really matters; and finally, algorithms, how we design clear, step-by-step solutions that a computer could follow. As you follow along, try to connect each pillar to situations you have already experienced in your studies, projects, or daily life. Let's start with the first pillar: decomposition. Decomposition means taking a complex problem and breaking it into smaller, more manageable parts. Instead of trying to handle everything at once, we deliberately separate the problem into sub-problems that we can focus on one by one. In practice, this could mean splitting a large project into phases, separating technical tasks from organizational tasks, or dividing a calculation into a series of simpler steps. Good decomposition makes it easier to plan, to assign work in a team, and to test whether each part really works. When we are able to clearly describe the sub-problems, we are already much closer to a clear and structured solution. The second pillar is pattern recognition. After we decompose a problem, we often start to notice similarities between different parts, or between the current problem and problems we have seen before. Pattern recognition is about identifying these repetitions, structures, and regularities. For example, many tasks follow a similar cycle: preparation, execution, and evaluation, even though the content is different. In mathematics or physics, the same type of formula or method may appear again and again in different questions. By recognizing patterns, we can reuse ideas instead of starting from zero each time. And we can design general methods that apply to a whole group of problems, not just a single case. The third pillar combines data representation and abstraction. Data representation is about how we choose to encode information so that it is clear and useful. We may use tables, diagrams, graphs, symbols, or numbers, depending on what we want to analyze. Abstraction is closely related. It means focusing on the information that is essential for solving the problem, and temporarily ignoring details that are not important at that stage. For instance, when modeling a system, we might represent it with a simple diagram and a few key parameters, rather than every small detail. By choosing appropriate representations and using abstraction, we reduce complexity, make communication easier, and prepare the problem so that it can be handled systematically or even automated later. The fourth pillar is algorithmic thinking. An algorithm is a precise, step-by-step procedure for solving a problem or completing a task. Algorithmic thinking means designing these steps so that they are clear, ordered, and unambiguous. Each step should be simple enough that it can be carried out by a computer or by a person who is following instructions. In computational thinking, we are not only interested in getting an answer once. We aim to find a repeatable method that will work for many similar inputs in the future. Later in this course, you will express algorithms using tools such as flowcharts and pseudocode, which help you to organize decisions, repetition, and control flow in a structured way. To summarize, computational thinking is supported by four connected pillars. Decomposition helps us break down complex problems into smaller pieces. Pattern recognition helps us see similarities in recurring structures. Data representation and abstraction help us choose what information to focus on and how to express it clearly. Algorithmic thinking helps us turn that understanding into step-by-step procedures that can be followed and implemented. In the next parts of this course, we will explore each pillar in more depth, and you will practice applying them to problems from your own discipline.